Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Killer Cages with a K by Dan Mudford, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have killer cages, where the grid contains cages of any number of cells indicated by dotted lines. And digits cannot repeat within a cage, and the digits within a cage must add up to the total given in that cage's upper left corner. So, for example, these two digits add up to 5, these 3 add up to 13, these 2 add up to 15, and these 5 add up to 18, etc., etc. So, as an example, if this were, say, a 9, this would have to be a 6 because these two digits must add up to 15. And that's an example of how killer cages work. We also have an arrow, where digits along an arrow must add up to the total given in the attached circle. So, for example, these two digits must sum up to the same digit as this cell. So, for example, if this were, say, 3 and 4, this would have to be a 7 because these two digits here must add up to what's in the circle. And that's an example of how arrows work. Another rule is the little killer rules, where clues outside the grid with diagonal arrows give the sum of the digits along the indicated diagonal. So, for example, these two digits must add up to 9, these two must add up to 5, these 6 digits here must add up to 38, and these, this is going to be, let's see if we can do this. These 9 digits here must add up to 53. So as an example, if this were, say, a 7, this would have to be 2 to add up to 9 because these two digits must add up to 9 because of the little killer clue. And that's an example of how little killer works. And finally, we have Kropke dots, where a white dot separates two digits that are consecutive. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive or have a difference of 1. That's another way of putting it. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first things first that I see are the cages, the killer cages that add up to 15, 5, 3, and 6. So there's only one possible set of two unique digits adding up to 3, and that's 1 and 2. There's only one set of digits, 3 digits that can add up to 6, and that's 1, 2, and 3. There's two sets of possibilities of two digits adding up to 5. That's 1 and 4 and 2 and 3 here. And to add up to 15, that would have to be 6, 9, or 7, 8 as the possibilities. Well, in this upper left-hand box, we have a 6, 7, 8, and 9 quadruplet, which eliminates 6, 7, 8, 9 in the rest of the box. So this must be 1, 2, 3, 4, 5. And we know these two digits add up to 5, so that has to be 1, 4, or 2, 3. That means the rest of these digits on this diagonal here, what do they add up to? Well, we have 15 already, times 2, and then 5. So that's 35 there, which means these three digits must add up to 10, right? Because 45 is the sum of all the digits from 1 through 9, and every box has to have the digits 1 through 9 in them because there are no repeats. These add up to 15 each. 30 plus 5 is 35. 45 minus 35 is 10. So this must be 10. What does... Okay, right. So it must be 10 as this has to add up to 10 on this diagonal. The most you can have on this diagonal here would be 3, 8, and 9. Well, what is that? That's 20 at most that you can have. So this would be at maximum right now for these three cells and these three cells. That's 10 here plus 20 here. That's 30. That means the remaining digits in this column, or sorry, along this diagonal, has to add up to at least 53 minus 30, which is 23. Well, the largest digit you can have in this 9 cage is 6, with 1, 2, and 6 adding up to 9. And that is also the minimum you can have along this diagonal, along with 8 and 9, for these to work. Since that's the minimum we can have, and it's a maximum cell we can have here, that must mean this must be 6, 8, and 9. This must be 3, 8, and 9, which adds up to 20. And this must be, obviously, 10. We already know this adds up to 10. This has to be 23, and this must be 20. And therefore, we know what this diagonal has to be. This is 6, and it's with 1 and 2 in the cage. This has to be an 8, 9 pair. This must be 3, with obviously this being a 1, 2 pair. And this having to be 8 and 9 to add up to 53. And that we celebrate the 3 in the corner because we know, actually, are we close to solving it? I'm not sure. Okay, let's continue. In this middle box, we have now a 1, 2, 1, 2 pair and an 8, 9, 8, 9 pair with a 6. That means the remaining digits in this box must be 3, 4, 5, and 7, guaranteed. We know these two digits add up to, or must be consecutive. 1, therefore, is odd, and 1 is even, because there's a difference of 1 between them. And adding up an odd number with an even number always gives you an odd number. So this must be either 3, 5, 7, or 9. Which makes this 1, 2, possibly, 2, 3, 3, 4, 4, 5. And those are the only possibilities here. These two digits add up to 9. So, it could be 1, 8, but this obviously is larger than this digit because these two digits add up to that one. So that would be 8 and 1, which would make that 7. It could be 7, 2, which would make this 5. It could be 6. It cannot be 6, 3 because of the 3 in the row. It could be 5, 4, which would make that 1. So those are all the possibilities for this arrow here. Remaining digits in this lower right-hand box have to be 4, 5, 6, 7 because of the 8, 9 pair and the 1, 2 pair and the 3 in the box. Okay, let's see. What else do we have? These two digits add up to that digit. You know, 5 is along that diagonal. That's fine. Adding up to 18. You have 5 digits adding up to 18. How many digits? What's the largest digit you can have in that cage? Well, if you have the lowest amount of digits, 1, 2, 3, and 4, the highest one you can have is an 8. Right? Well, that means where is the 9 in row 7? It cannot be here because, again, the highest digit in this cage is 8. Cannot be here because these two digits add up to another digit. So this is never 9. And these can't be 9 because of the 8, 9 pair in the box. So the only possible place for 9 in row 7 has to be here. So this is 9, this is 8. Well, what is the possible... Where can 8 be in row 7? Can't be here because of, again, of the 8 in the box. Can't be here because it adds up. These have to be consecutive, adding up to another digit. And 8 and 7 add up to 15 at minimum. So 8 has to be in the cage, which forces this cage to be 1, 2, 3, 4, and 8. That eliminates 1, 2, 3, 4 in the rest of the row. So this can't be 1 through 4. This must be 5. 5 is consecutive with 4 or 6. But 5 and 6 adds up to a 2-digit number, which is not allowed in a single digit. So this must be 5 and 4, which makes this 9. This cannot be 5 or 4 because of the 1, 2, 3, 4, 8 quintuplet and the 5 in the row. That makes a 6, 7 pair, which eliminates 6, 7 in the rest of the box. So this can't be 6 or 7. This can't be 4 because of the 4 in the row, so this must be 5, which makes this 4. That eliminates 1, 4 as a possibility in this 5 cage. So that's a 2, 3 pair here. 4 cannot be here because of the 4 in the box. This 8 eliminates 8 and 1 as a possibility here. This 4 eliminates 4 and 5 as a possibility here. Therefore, this must be 2 and 7 adding up to 9, which forces this to be a 5 here. This 2 eliminates 2 here, so that's 1 and 2. None of these can be 2 because of the 2 in the box. This can't be 1 because of the 1 in the column. Neither of these can be 1 or 2 because of the 1 and 2 in the column, and this can't be 2 here because of the 2 in the column. Where is the 2 in this upper left-hand box? It must be this cell. So this is 2. These two digits add up to 5. You don't have 2 and 3, so this must be 4 and 1. That leaves these digits as 3 and 5, and this 5 eliminates 5 here, so this is 3, which makes that 5. We have another 3 in the corner, which means we can celebrate because we know we're getting close to solving this. This 3 eliminates 3 here, so that's 2, which makes that 3. And these digits add up to 38. Is that helpful? Not right now. This can't be 1 or 3 because of the 1 or 3 in the column. And this can't be 7 because of the 7 in the column. That eliminates 8 as a possibility here, because if this is 8, that would have to be 7, and that's a contradiction. This can't be 4 because of the 4 in the column. These digits cannot contain a 3. What are the possible combinations of digits that can add up to 13 then? Can't be 139. It could be 148 as long as one of these is 1. Not this one. So this digit cannot be 1, 2, 3, 5. So that means this is 4, 6, 7, 8, or 9. But if you have a 9 here, it's guaranteed to be with 1 and 3 in the rest of the cage, but that's not allowed because of the 3 in the column. So this can never be 9. So we could have 8, 1, 4. Right? If this is 8, it cannot be 2 and 3 because of the 3 in the column, so that would be 1, 4. It could be 7, 1, 5, or 2, 4 if this is 2. It could be 6 here. That means these would add up to 7. And it can't be 1, 6, obviously, because we'd have a 6 there. It can't be 3, 4. It'd have to be 2 and 5. Or this is 4, which means these two must add up to, what, 9? Yes. And it could be 1 and 8, but if 8 were here, that would force us to be 1 already, which is not allowed, so this can't be 8. So that could be 1, 8 that way with 4. 2, 7 works as long as that's 2 and that's 7. 3, 6 obviously doesn't work, and 4, 5 doesn't work. So those are all the possibilities here. Remaining digits in column 7. That's probably the easier way to go. We have 1, 6, 7, 8 left. Well, 1 is only consecutive with 2, so this can't be 1 because of the 2 already in the row. This can't be 6. This can't be 1 because of the 6 in the row and the 1 in the row. So 1 has to be one of these two digits, which means this can never be 1 here. Interesting. So, where is 1? Well, we don't have actually that information either. Where should we go next? This 4, 5 pair eliminates 4 and 5 in the rest of the column. So this can't be 4 or 5. That means in the central box we have a 3, 7 pair, which eliminates 3 and 7 in the rest of the box. So this is 4 or 5. That means the rest of row 6 has to be 3, 6, 7, 8, and 9. Okay, and 3 cannot be here because of the 3 in the column. This can't be 8 because of 8 in the column. Where is the 3 in column 8? Can't be here because of the 3 in the box. Can't be here because of the 3 in the box, so it must be one of these 3 cells. Where is the 9 in this lower left-hand box? Cannot be here because of the 9 in the row. Can't be here because of the way that the cage is set up. So it must be here. So this is 9, which eliminates 6 and 9 as a possibility here to add up to 15. This 7-8 pair eliminates 7-8 in the rest of the box and the rest of the column. So it cannot be 7-8 here. This can't be 8. This obviously can't be 7 or 8. This is 6 and 9. This 6-9 pair eliminates 6 and 9 in the rest of this row. So this cannot be 6, and this can't be 6 or 9. Well, what's 7 and 8 consecutive with? 7 and 8 can be consecutive with only 6, 7, 8, and 9, and 6 or 9 are ruled out here. So this must be 7 or 8, but this can't be 7 because of the 3-7 pair in the column. So therefore, this must be 8, which makes this 7, which eliminates 7 in the rest of the box. Also, this can't be 8 because of the 8 in the row. This 8 eliminates 8 here, so it's 9. This 9 eliminates 9 here, so it's 8. We actually could have done that much earlier, but I guess we didn't. This can't be 9 because of 9 in the row. These can't be 9 because of 9 in the row. Where is the 9 in this right central box? Cannot be here because of 9 in the row. Can't be here because 9 in the column. Can't be along the arrow because 9 with another digit adds up to 10 or more, which is not a single digit. And this must be a single digit. So 9 has to be one of those two digits. Therefore, where is the 9 in column 9? Cannot be any of these because one of these two must be a 9 because it can't be along the arrow, and it can't be here because of the 9 in the row. Can't be here because of the 9 in the box. Can't be in this cage because it must have 1 and 3 adding with it to add up to 13. So this must be a 9 here. Where is the 9 then in column 4? 9 cannot be here because of the 9 in the box, can't be here because of the 9 in the box, can't be here because of the 6-9 pair in the row, and can't be here because of the 9 in the row. So 9 has to be here. This can't be 8 because of 8 in the column. This 2 eliminates 2 here, so that's 1, which eliminates 1 here, so that's 2. This 2 eliminates a possibility of a 2 in this row. Where is the 2 in column 8? Cannot be here because 2 in the box, can't be here because 2 in the box, can't be here because 2 in the row, so it must be one of these two digits. Well, we know 9 also has to be there. 2 cannot be the sum of 2 unique digits, so this cannot be 2. Therefore, this is 2, which forces this to be 9, which forces this to be 3. That makes this 6, which means this can't be 6. This can't be 6. So we have a 7-8 pair in this right central box. That eliminates 7 and 8 in the rest of the box. So this can't be 7. And this 7 eliminates 7 here. So that's 8, which makes that 7. This can't be 7 or 8, so it's 1. This can't be 1, 7, or 8, so it must be 6. This 2 eliminates 2 here, so it's 1, which makes that 2. This can no longer be 1 here. This can no longer be 2. Where is the 2 then in row 7? Can't be here because of the 2 in the box. Can't be here because of the 2 in the column. Can't be here because of the 2 in the box. So it must be this cell. So this is 2. This adds up to 9. And you can only have a 4 or 5 here. Because it cannot be 1 and 8, so this must be a 4 or 5 pair, which eliminates 4 and 5 in the rest of the column. This 7 eliminates 7 here, so it's 6, which makes that 7. This can't be 4 or 5 because of 4 or 5 pair in the column, so this is 1. This can't be 4 or 6, it must be 8. 1 and 8 add up to 9, plus 4 adds up to 13, which makes this a 5. These digits are consecutive, and the remaining digits in row or column 8 have to be 4, 5, and 6. But this can't be 6 because of the 6, 9 pair in the row. So this must be 4 or 5, and 6 is guaranteed to be in next to the white crop key dot. Well, 6 is only consecutive with 5 out of 4 and 5. So this must be a 5, 6 pair. This can't be 5 because of 5 in the row. So this is 6, this is 5, and that's 4. Okay, let's continue. This is just now all normal Sudoku stuff. This 8 eliminates 8 here, so it's 7 and 8. We should have a lot of 2s. We do. We have 8 2s. We know where the last 2 has to be. It has to be here, so that's there. We have not enough 1s, but probably enough information. This 1 eliminates 1 in this lower central box in this column. This 1 eliminates 1 here. Where is the 1 in this lower central box? It must be here. So this is 1 which eliminates 1 here. That means where's the 1 in this upper central box? Cannot be here because the 1 in the column. Can't be here because this 1 in the column. And these are filled, so this must be a 1 here. We now have 8 1s. We know where the last 1 has to be. It has to be here. We have 2s already done. 3s. We probably don't have enough. Well, no. Well, we have some information. This 3 eliminates 3 in the rest of the row. That means in this lower central box, where's the 3? It has to be here. Where's the 3 in column 5? Can't be here because the 3 in the box. Can't be here because of the 3 7 pair in the box. And can't be here or here because of the 3s in the rows. So it must be here. We don't know where it is in this left central box, and we don't know where it is in this lower left box. So that's 3s. 4s, where's the 4 remaining in row 2? It has to be here. That eliminates 4 here, so it's 5, which makes that 4. We don't have any other extra information, so let's go to 5s. Where can 5 be in row 3? It has to be here, because this is 6 9 pair. We have 8 5s. We know where the last 5 has to be. It has to be here. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 5s eliminate these, and this 5 eliminates 5s there. So we have all the 5s, 6s. Where is the 6 in the lower left hand? Well, actually, row 8. It has to be here. This 6 eliminates 6 here, so it's 9 and 6. Where's the 9 in row 1? These are all filled out, and 6 cannot be here because of the 6 in the column, so it must be here. And that gives us 8 6s, so we know where the last 6 is. It has to be here. 7s. Where is the 7 in row 1? It must be there. Where's the 7 in column 5? It must be there. And we don't have any other information about 7s. So let's go to 8s. Where's the last 8 in column 4? It must be there. We don't have any extra information about that then. 9s. We have 8 9s, so we know where the last 9 has to be. It has to be here. So this is 9. And then we can keep going. So 1s are done now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2s are done. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3s, we still don't have enough information, but 4s, we now have enough information to disambiguate. Particularly in the left central box. This can't be 4 because of the 4 in the row, and this can't be 4 because of 4 in the column. And we had the 9 now to eliminate that possibility. So where's the 4 in this left central box? It has to be here. That 4 eliminates 4 here, so this is 3, this is 8, this is 4. That should give us 9 4s, right? Yep. And then everything else we can just fill out. We have already all 9 5s. We have all 9 6s, 7s. We still can't disambiguate yet. 8s, we can, because we now have 8 8s, so the last 8 has to be here. 9s, we have 3, we have all 9 9s, so then 3 again. Wait, do we? Hold up. Ah, right. We didn't have this disambiguation, so this was 3 7. We have to use a little killer clue. That's here. This adds up to 11. Plus 6 is 17. So that means there's 21 remaining in this diagonal. Well, that must be 6 and 8. 21 minus 6 and 8 is 14, which is 7. So this must be 7. That makes this 3, which makes this 7, which makes this a 3. And that's a solution. Yep, fairly straightforward. Obviously, there's going to be some things like, for example, knowing that this diagonal was very restrictive. To sort of, I guess, yeah. I mean, this is just something that that sort of comes with experience of doing like little killer clues or killer cage Sudoku. You start noticing when things are limiting. And for example, I knew this had to be 10 because of the limitation of that box. Actually, that one's just simple math, right? And then I knew that was important because this was limited here. And then this was limited. So that fixed essentially this diagonal for what it could be. And then everything flows very smoothly from there. Yeah, I don't know. It's just something that you'll get if you do enough Sudoku puzzles, you'll start getting these sort of senses of what is restrictive and what isn't. Sometimes you won't. Sometimes, like, I just go down paths and then, well, I see something that I think is restrictive and find out it's actually the solution path because it just keeps going down and it still keeps working. So sometimes you'll run into that situation. But a lot of times you will be able to see sort of things after enough experience to be able to go, oh, this is a really limiting factor here. How, like, I should probably pursue this to see where it leads to, right? So I don't know. That's I guess a sort of tip that I would give to people is basically start noticing where you're being restricted in these puzzles, and that will start hinting at what you can like look at. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.